Hello everyone. Through this video we are going to discuss from question number 6 in exercise 6.3. So in question number 6, what do we have? It is stated that for each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also find the square root of the square number so obtained. So in this case we are having in total 6 questions, so I shall be picking up a few important questions out of this. The rest can be proceeded in the same way. So here I shall be starting with the first question, that is Roman 1. So the quantity given here is 252. So first of all, in this case we shall try to find out what are the factors of 252 by prime factorization. So let us check in the solution part. Solution by prime factorization. By prime factorization, what do we get? 252 is equal to like this. We have to do factorization. 252, since this is an even number, we can start dividing by 2. So I shall be getting here 2 1 ja 2, then 2 2 ja 4, it is 12, 2 6 ja 12, then again by 2 I can divide it, so it is 6, then this is 3, then again by 2 it is not possible to divide, so we shall be proceeding with 3 since this is an odd number, and the sum of these two digits is equal to 9, which is divisible by 3. Therefore 63 will be divisible by 3, and I'm going to get the result as it is 2. Then after, what do I get? It is 1. So after this, by again by 3 I can divide it, so the result will become 7. So the factors can be listed in this way: 2 into 2 into 3 into 3 into 7. What do I find here? The prime factor 7 is not paired here, so in this case 252 must be divided by 7 to make it a perfect square. So I'm going to write here, since the prime factor 7 is not paired, therefore the number 252 is to be divided by 7 to make it a perfect square. So here in this case, what do I get? After this I have to perform division. Therefore 252 when divided by 7, what result can I get here? Let us check once. 252 when divided by 7, the result will come as 7 3 ja 21, then 4 2, 7 6 ja 42. So ultimately result comes as 36. So here in this case we are further asked to find out the square root of the square number so obtained. So here in this case the resulting number 36, we have to find out the square root. So what do I get? Therefore root 36 will be equal to, what do I have to write here? These 4 elements I have to write, like 2 into 2 into 3 into 3. So from each pair of numbers 2 and 3 will come out, and the answer comes as 6. So this is the answer. Next, after this I'm going to pick up Roman 2. So this is Roman 2 under this question. So what do I have? The given number is 2925. That means 2925 is a number given. I have to find out that number by what this is to be divided to make it a perfect square. So coming to the solution part, what do I get? Exactly as the previous question, we have to proceed by prime factorization. By prime factorization, what do I get? 2925 is equal to, let us proceed with prime factorization. 2925, very clearly it is not divisible by 2. Let us check whether it is divisible by 3 or not. Let us find out the sum of the digits. 5 plus 2, it is 7. 7 plus 9, it is 16. 16 plus 2, 18. So 18 is a number which is divisible by 3. So we can proceed with division by 3. So 3 9 ja 27, then 22, 3 7 ja 21, then 3 5 ja 15. Then after, let us check whether it is divisible by 3 or not. Yeah, 16 plus 5, it is 21. Sum of the digits is 21 here. So further it is divisible by 3. So 3 3 ja 9. Then after we shall be getting 2 5. Then further, will it be divisible by 3? No, because the sum of the digits is 10 here, which is not divisible by 3. So we have directly to skip to 5. So since the units place is 5 here in 325, so this number will be divisible by 5. We can proceed with 6. So 6 5 ja 30, then 5 5 ja 25. Then again by 5, 5 13 ja 65. So what can I write here is 3 into 3 into 5 into 5 into 13. So we can find that this number 13 remains unpaired in this part. So this whole number is to be divided by 13 to make it a perfect square. So let us check. What can I write? Since the prime factor 13 is not paired, 13 is not paired here, therefore to make 2925 a perfect square, it must be divided by 13. Therefore we get here 2925. When divided by 13, we shall be getting, the result is, actually in this list these factors are there, 3 3 5 5 excluding 13. Let us check what we get. 3 3 ja 9, then here in this case it is 5, so 5 5 ja 25. So in total the product will be 225. Now let us check it once by dividing. We should get the result is 225. So 2925 when divided by 13, 13 2 ja 26 it is, then 32 is left, again it is 2 ja 13 2 ja 26, then after 65, then after let us check what we get. 13 5 ja 65. So our answer becomes 225. Now let us find out its square root. 225 is equal to, just excluding 13, the rest of the terms we can list here, 3 into 3 into 5 into 5. So amongst is just exactly one terms we have to take out. 3 into 5, the result comes as 15. So this is the required answer for this part. Then after, one more term I'm picking up here. So I'm proceeding with Roman 4. So here goes Roman 4. The rest of the questions are exactly similar to this only. What method we are proceeding with, exactly in the same way we have to do. So this is Roman 4 here, and the number given is 2645. 2645. So by prime factorization, let us check what we get. By prime factorization, 2645 is equal to, let us find out the factors now. So 2645. Can we proceed here with 3? Is it possible? Let us find out the sum of the digits. 4 plus 5, it is 9. 9 plus 6, it is 15. 15 plus 2, it is 17. No, this is not possible here to proceed with 3. So directly we have to start with 5. 5 5 ja 25. Then 14 is left. 14, 14 will be there. Then 5 2 ja 10. Then 5 9 ja 45. So 529 I get here. Then we already know that this is divisible by 23, because 23 into 23, I get the result as 529. So here goes 23 into 23. All these three numbers are prime numbers. So, and suppose here in this case I know that 529 is a product of 23 and 23, but the cases where we do not know that what factor next I should write, we have to go on checking with the numbers. Like after 5 it is 7, then after those terms which are not divisible by 3 will not be divisible by 9. Then after next, if it is not possible by 7, then we have to come to 11. The next prime number is 13. The next prime number is 17. In that way we have to go on unless and until we get the exact result. Two big values will not be given in these cases. There will be a limit. So in that way we can proceed here. So what do I get here is 5 into 23 into 23. So we find that this number, this first number, I mean 5, is unpaired. So to make it a perfect square, I have to divide this number by 5. So what I'm going to write is, since the prime factor 5 is unpaired here, therefore 2645 must be divided by 5 to make it a perfect square. So after this what I shall get, therefore 2645 when divided by 5, of course we find that when 5 is removed among these factors, 23 and 23 will be left behind. So product of 23 and 23 is 529. So the quotient that comes here is 529, and ultimately we get here, and square root of 529 will of course be excluding this 5. I shall have to write 23 into 23, and only 123 will come out from this pair, and this is the required answer. So that's the way the questions of question number 6 can be solved. Next I shall come to question number 7 of this exercise. Coming to question number 7. So here goes question number 7. Let us check what it says. The students of class 8 class 8 of a school donated rupees 2401 in all for Prime Minister's National Relief Fund, for PM's National Relief Fund. Each student donated student donated, each student donated as many rupees as the number of students in the class. Find the number of students in the class. Find the number of students in the class. So here I get that the total amount of money contributed here is 2401. The prime condition given here is what? Each student donated as many rupees as the number of students in the class. Find the number of students in a class. That means suppose in a class there are 24 number of students. Just for example I am considering, if suppose there are 24 number of students in a class, then each student will contribute 24 rupees 24 per head, means every student will offer rupees 24, because it is given that the number of student is equal to the amount of money offered by or donated by each student. So here in this case, if I consider that the number of students is X, then amount of donated money will also be X. Yes or no? For each student, the donated amount of money will also be X. So what can I write here? In the solution part, I shall be writing given total amount of money donated is equal to rupees 2401. Let number of students is equal to X. Therefore, amount of money donated by each student is also equal to X. Why so? Because in the condition it is already given that the number of students is equal to amount of money donated by each student of the class. So according to question, what can I write? According to question, number of students into amount donated by each student is equal to 2401 rupees 2401. This implies number of students already we had assumed as X, and at the same time what do I have? The amount of money donated by each student is also X. So I shall be getting the result as 2401. And what do I get here? X square is equal to 2401. So the next step is what? I have to find out square root of it. That means X will be equal to square root of 2401. So by prime factorization I have to find out the factors. What do I get? 2401. Very clearly it is not divisible by 2. Then it is not divisible by 3 also. By 5 also it is not divisible. By 7, if we check it, yeah, it is divisible by 7, because 7 3s are 21, then 3 0, 7 4s are 28, then again 3. Then after, this number is further divisible by 7. So I get here 7 4s are 28, then 63, 7 9 ja 63 by 7, this is again 7. So what do I get? Is equal to 7 into 7 into 7 into 7. By the side we shall be writing by prime factorization. The method we are opting for, we must have to mention by prime factorization. Okay, then from each pair I have to take out one number, so it will be 7 into 7 ultimately. So x is equal to 49. So the number of students is equal to 49. So that is how we have to evaluate. Therefore, the number of students is equal to 49. So this is the answer. Now let us come to question number 8. So in question number 8, what is said? 2025 plants are to be planted in a garden sorry, there is a correction. In a garden in such a way that each row contains as many plants as the number of rows. Find the number of rows. Find the number of rows and the number of plants in each row. This question is exactly similar to the previous question only. So here goes the solution part. Total number of plants we get as 2025. The prime condition given here is what? Each row contains as many plants as the number of rows. Means how many plants? I mean in each row, if I plant suppose x number of rows, then in total there should be actually I mean to say, if suppose in a row there are x number of plants, then in total there should be x number of rows. So what I am going to write is here let the number of plants is equal to x, that is equal to again number of rows, means both should be same. So according to question, total number of plants to be planted is equal to 2025. That implies what? Number of plants into number of rows. There is a correction, number of plants in each row. It should be very clear then. So this is one part, this is other part, that is equal to 2025. So after this, what do I get? X into x, that is equal to 2025. So I get here x square is equal to 2025. So then after I get x is equal to square root of 2025. So by prime factorization I am calculating, actually I am trying to find out all the factors of 2025. So 2025, is this number divisible by 3? Yes, this is divisible by 3. 3 6 are 18, then 22, 3 7 are 21, then here it is 5. Then again by 3 it is divisible, 225. Then again by 3 it will be divisible, 7, then 5. Then further, what do I get? Again by 3 it is divisible, 25. Here it is 5, 5. So in total I am getting these factors. So under root sign, 3 into 3 into 3 into 3 into 5 into 5. So from each pair I am taking out one number. So I get x is equal to 3 into 3 into 5. So my answer will be x is equal to 3 3 ja 9, then 9 5 ja 45. So here in this case, what do I get? I get as total number of plants. In the question it was asked at the number of rows and number of plants. Therefore, number of rows is equal to 45. Then again, number of plants in each row is equal to 45 again. So, this is the answer. Then, question number 9 and question number 10 are exactly of same kind. So, here goes question number 9. In question number 9, what is given? Find the smallest square number. Find the smallest square number that is divisible by 4, 9 and 10. Divisible by 4, 9 and 10. So coming to the solution part, we have to choose that kind of number which is divisible by all these three numbers 4, 9 and 10, and that can be only one number, that is what? LCM of all these three numbers. So here I find LCM of 4, 9 and 10 is, so let us find it out. What could be its LCM? 4, 9 and 10. First I have to take the number 2 because out of these three, two numbers are divisible by 2. So 2 2 ja 4, 9 will remain as it is because it is not divisible by 2. So 2 5 ja 10 here. So we find that amongst these 5 is not divisible by 3, only 9 is divisible by 3, and I can proceed with 3 if I want. If I do not do this, then also there is no problem. So 3, then 5. So let us calculate. 3 2 ja 6, 6 6 are 36, then 36 into 5, we get the result to be 180. So it is 180. Now by prime factorization, we get what? We get that 180 is equal to, let us proceed with prime factorization. By 2 it is 90, again by 2 I get here 45, again by 3 I get 15 here, again by 3 it is 5. So I get here 2 into 2 into 3 into 3 into 5. So to make it a perfect square, I have to divide this number 180 by 5 so that I can get a perfect square. So either I have to divide this by 5 or I have to multiply this by 5 to make it a perfect square. So what is asked? Find the smallest square number that is divisible by this 3. If I divide this by 5, then this term 5 will be getting removed from 180 and it won't be divisible by 10. So I have to multiply this quantity 180 by 5 so that I get the smallest square number that is divisible by 4, 9 and 10. Since 5 is unpaired here, therefore to make 180 a perfect square, we have to multiply that. We have to multiply it by 5. We have to multiply it by 5 and then we get 180 into 5, that is equal to 900, and this is the smallest square number and it is the smallest square number visible by 4, 9 and 10. Thank you.